Now, see a motional EMF, that is a motional electromotive force. See, in this case there is a rectangular frame and a conducting rod PQ is placed here, and that is in the magnetic field. There is a uniform magnetic field. Direction of magnetic field is here actually, that is into the plane or inward to the plane perpendicularly. Now, this rod PQ is moving on this frame with velocity v inward. So, when this rod PQ moves inward, what happens? There is a decrease in the area, as a result decrease in magnetic flux. So, due to this decrease in magnetic flux, it means magnetic flux is changing with the time. And according to Faraday's laws of electromagnetic induction, whenever there is a rate of change of magnetic flux, EMF is induced. So, see here, when the rod PQ is moving inward, there is a decrease in magnetic flux. So, the current will be induced, and induced current is here in such a way which opposes the decrease in magnetic flux. So, now see here, if I take direction of current here clockwise like this, then you will find here the magnetic field due to induced current is also into the plane or inward to the plane, which is actually supporting in increasing magnetic flux. So, the direction of current in this loop will be here clockwise. So, and whatever the EMF is induced in this process on the rod PQ here, that is called motional EMF, because of this movement of the conductor in magnetic field. And now, see here, the length of this rod PQ is L. So, suppose this length we can write here L, and the distance from here to here, that is x. So, when this rod PQ comes from here to this end, there is a decrease in area, or area you can say completely reduces to 0. So, when the rod PQ covers the distance x, so there is a decrease in area. So, we can write here change in area is, that is minus L into x. Negative sign I have introduced here for decrease in area. So, now EMF induced can be written minus d phi upon dt, and that is here minus. So, the change decrease in area we have got. So, we can get the magnetic flux also. So, magnetic flux you will be getting here B into minus Lx. So, in place of flux here we can write this one. So, E is equal to minus d upon dt, and here we can write minus Blx. B and L both are constant. So, the dx upon dt, so that can be written E is equal to Blv, where V is the uniform velocity of this rod. So, this is the EMF induced in the rod PQ here, and whose magnitude is equal to Blv. This is known as here motional EMF. So, see here in this case we have seen induced EMF. So, we can also calculate current. Let R be the resistance of the rod PQ. So, suppose R is the resistance of rod of PQ basically here. So, we can write I is equal to E upon R, that is here BLV upon R, that is the magnitude of the current. Now, when current is flowing through the rod PQ, it experiences magnetic force also, because this current carrying rod is in the magnetic field. So, we can also write magnetic force is equal to here I into L cross B, and that will be here this magnetic force that will be acting outward to this side here. So, magnetic force will be acting outward, and we can write here ILB, because theta here we can take 90 degree. So, we can put the value of I. So, we will be getting here F is equal to magnitude of the force is equal to B square L square V upon R. So, this is the magnetic force acting on the rod PQ. So, also there is energy is dissipated in this form, because some work is done against this force, and whatever the work is done, that also we can calculate, or that is called actually the power. So, we know it, power is equal to force into velocity, we know it. So, power is equal to force into velocity. So, that is your B square L square V into V divided by R. So, that will be a B square L square V square divided by R. So, this is the power here, right, that is coming in the form of the heat is here also, that is called a dissipated power, and this is actually mechanical work here in this case. So, we have seen also the energy consideration or the energy, power and force acting on the conductor, that is PQ here. So, this is about the motional EMF.